So we're going to have a look at some of the time zones, and we will have a look at how that works with you guys. So we'll show you just a few examples of really how we can calculate different times and time zones. So, I mean, the first thing we've got to understand is that we live on a planet, right? And we have time zones because, I mean, normally, daylight is in, from, I don't know, anywhere from 6 a.m. depending on where you live. Sometimes it's at 2 a.m. kind of to, 8, 9 p.m. or whatever. So we've got the world, and the world goes around, and it's never the same time in two places. In local time we're talking about. Now, absolutely in universal time, I mean, it is always the same time, like in point of time, but we change our clock based on, the sun, when the sun gets up and when it goes to bed, and that's sort of what governs our time in different places. So, you've got the morning, you've got, midday, you've got the afternoon. That's sort of what really bases it. So each area has different times. Now, if you think about it, like you've got 24 hours in a day, right? And there's 360 degrees, right? There's 360 degrees in the planet. If you divide these two together, you will note that, well, if you go 360 divided by 24, you get 15. So what does that mean? Well, per 15 degrees is equal to about a 1 hour change. So where is universal time is 0 is in Greenwich, because we talked about that last lesson. That's at 0. So if England is at 0, and that's sort of England here, which is Greenwich, and Australia is like right around the globe on the back, and we're at about 145 degrees east, if you remember. So roughly, how far difference would the time be from here to here locally? Well, if 15 degrees is about 1 hour, all we need to do is take 145 divided by 15. It's approximately 9.9 hours, approximately 10 hours. So we are 10 hours. Are we behind or in front? Now, that's a really good question. We're actually in front of them. So if it was, just say, for example, 10 hours in front of them, we'll get that a bit later. I don't want to go too much there. Why? If we spin the Earth around and we look at the back, there's this thing called the International Date Line, which kind of goes here. New Zealand's on one side, and you've got Australia here. All right, that's sort of my Australian map. Okay, and then you've got all your Asian, Papua New Guinea, you've got the continent of Asia, Malaysia, and so on, all around scattered through here. This is your international date line. This is when the first day comes. Okay, so we get New Year's first. Hawaii's over here. So you can actually have a whole New Year's party, and then you could fly from here and still get to Hawaii on New Year's Eve. So you could have like a whole massive New Year's Eve party, enjoy a bit of New Year's Day, fly across, and then you'd land here on New Year's Eve and you could start partying again, probably about midday. Why? Because if you think about it, it's split up to 24 hours. So really, if it was like, for example, let's just go with 2 p.m. in Australia, well, you would have to minus 10 hours back to figure out what time it is in England, because that hasn't happened yet. We've had our morning and afternoon because the sun's come here, and the Earth rotates this way. So it's going to rotate that way. So it will, come around. So, 2 p.m. So the earlier, if you think of the sun, if it's 2 p.m., the sun will be here. It'll just be rising, over in England. So how do you figure that out? Well, 2 p.m. is actually 1400. Minus 10 hours off that, it would be 4:04:00. So it'd be 4 a.m. the same day. Now, if you want to go to Hawaii, now Hawaii has, I think, a distance of about, west, I think it's about 170 degrees west. So if you think about that, that's got to go right around. So the difference between these two in date lines, because we're at about 145 plus 170, so 145 plus 170, and if you're confused, that's okay, don't worry, because we're going to explain a bit more, is 21 hours, okay? So if it was 2 p.m. here, so say you just had your New Year's Eve, and now it's New Year's Day, it's 2 p.m., and you want to fly off to Hawaii, it takes about 4 hours. what time would it be in Hawaii? So let's see, if you took off at, let's just say, you know, well, 2 p.m. is a bit late. Let's just say you took off at 10, right? You took off at 10 a.m., right, on New Year's Day. 10 a.m. What time would it be in Hawaii? Well, the time it would be in Hawaii is 21 hours before that. So we're just going to take, how I would do this is go, well, it's 10 a.m. on New Year's Day, minus 21 from that. 10 minus 21. So it's negative 11. So what does that mean? Negative 11. Now, if it's a negative 11 hours, so negative 11, so it's negative 11 from midnight, right? Because you got to go back. So 11 hours from midnight would take you to 1 p.m. Yep. So the time there would equal 1 p.m. So that would be 1300 on New Year's Eve. Now, you could leave at 10 a.m. in Melbourne and land, and if it takes 4 hours to fly to Hawaii, it might take a bit longer depending where you're leaving from. If you're leaving from Brisbane, I think it's a bit quicker. If it just say if it takes 4 hours, you're going to get there at then 13. You're going to get there at 1700, 5 p.m. just in time for a whole new party. So that's what you can do. Fun times. So how do these times work? So we use normally 15 degrees. Now, typically each 15 degrees is locked into a time zone. So you'll notice that that's why the globe is actually split into these 15-degree increments. So everything here is normally in the same time zone. So you'd have, you know, all the same time. So if you look at Australia and you think about, that's a really bad map of Australia, but it will do. It's like an Arnis picky shape. So you'll notice that everything here, we all have the same time zone except for Queensland and daylight savings, but let's just assume we're all locked in. Why? Is because we all fall within this 15-degree increment. So rather than sort of saying, oh, you know, there's time difference between these two is slightly different in terms of when the sun would rise, but we'd all set our clocks at the same time. Then we've got a different time here, and we've got a different time over in, Perth as well. So there's slightly different times as we move through. Now, if Perth is 2 hours behind, it's going to be about 30 degrees or plus a bit further. So when we're dealing with time zones, we sort of put everything in so then we can have approximately the same time when we're doing that. Now, that's slightly different. Now, obviously, some things that you do need to note of is that the sun always rises in the east. So one important thing. So the further east you are, like if you think about this as the sun, right? Okay, and this may sound stupid, but it actually will help you. If you think about the globe, now the globe is here, right? And what will happen is the Earth, don't forget, spins that way, okay? It spins this way, okay? So if Australia is over here, right, on the far side, I mean, you know, and that's still, you know, you're still going to have a shadow, right? I mean, you're still going to be in the dark because the sun is shining light all on this surface. So it's dark here, it's nighttime, but it's spinning this way, right? So what's going to happen is as it gets closer and closer, Australia will move across, right? And now it's just going to be in the sun, okay? So as it moves across, so that's when it sort of starts to come into light of the sun. So who will get the sunrise first? Well, it'll be the person who's most easterly, because here it would still be where you're, you know, we've got north, we've got east, we've got south, we've got west, because that's the way the Earth spins. So you're going to see it. So some typical questions you'll get is something like this. It'll be like, you know, we live in Victoria. This is a good classic one from a while ago. I can't quite remember. So you live in Victoria, right? This is sort of a map of Victoria. It's a pretty bad map, but it's a quick idea. Okay, that's kind of like the state of Victoria. Now just say, you know, you're living in Melbourne, right, over here, and you also got someone's over here on 90 Mile Beach, okay? Now, let's look at the coordinates of this. Let's say that this is, doesn't really matter where you're south or north, but let's just keep it the same. Let's look at how far east we are. So let's say this is more easterly. So let's say this is 149 degrees east, where this is 145. Now, if I see the sunrise here, 6:30. What time did it rise over here, given that we're in the same timeline, so same time zone? So if we are in the same time zone, what time did the sun rise? Now, if we're in the same time zone, that means like at 6:30 here, you'd still be at 6:30 here, right? So everybody has their watch at the same thing. Did the sun rise? At East 149. Now, what you've got to recognize is that we know every 15 degrees counts for every hour. Or we can say that, you know, there's 360 degrees and there's 24 hours. So, you know, if we go 360 divided by 24, you're going to actually find out that 15 degrees per hour, right? So if we've got that rate, how many degrees difference is this? Well, there's 4 degrees difference. So obviously the sun's going to rise earlier here. It's going to hit here first because we're in the same time zone. It's a bit different. So if there's 4 degrees difference, well, it's 4 degrees divided by 15. It's actually 0.266667 of an hour. So now I can times that by 60 minutes. So it's going to rise 16 minutes difference in that 4 degrees. So we know that. How do we do that? So what we did is we know that there's, if we go 149 minus 145 degrees, we know that there is a 4 degree difference. So therefore, what we can do is we can go, well, 4 divided by 15, because it's 15 degrees per hour, gives us 0.2, let's just round off, hours. So we now, whoops, so we now what we did is we then go 0.26 dot, 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 dot. We don't round off. I'm just going to actually do that as dot, 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 times 60 to get 2 minutes, and that equals 16 minutes. So therefore, if the sun's going to get up early, it would have risen 16 minutes earlier than this. So 6:30 minus 16 minutes would be 6:14. So the sun rose here actually at 6:14 a.m. Now that kind of makes sense because it's going to slowly come around, rise over here first, and then, you know, the sun's going to come across as the Earth rotates. So, you know, this picture would actually be moving to the left, but because the light sort of stays where it is, but as it gets here. Now, if you had another point over here, and let's just say that was easterly let's just go with 52, right? What time would the sun rise there? Now, obviously, it's going to be a bit later because it's more westerly. So the more westerly, the later it is. The more easterly, the earlier, you know, it rises the sun. So the difference here is 7 degrees. So again, we'll just go, well, 7 degrees divided by 15 gives me that much of an hour. Times that by 60, that's actually 28 minutes. So 28 minutes from 6:30, the sun rises here at 6:58 a.m. And that's how we can do it because we're all in the same time zone. So it's slightly different. So that's something I like to call like solar time or lunar time, okay, where it does it and we can get to the exact understanding. Really, if you want to think about every degree in terms of hours, well, there's 360 degrees, right? If you divide that by 24, we know it's 15 degrees is per hour. So 15 degrees to an hour. Now, if we divide that by 60, every degree, you know, that we're talking about, sorry, I've done that the wrong way, 60 divided by 15, every degree equates to 4 minutes. Every degree equates to 4 minutes. So that's another shortcut you can do. So one thing you can say is, you know, for this, every degree equals 4 minutes. So you could just go, oh, 4 minutes between these. That's 4 degrees. That'd be 16 minutes. Here, there's 7. 7 times 4 would give you 28. So every degree equals 4 minutes time difference. But that's more not like actual time. It's more talking about the sunrise and where they go. So this gets quite tricky, this concept. But let's work through a couple of examples and try and unpack that a little bit more for you guys. Yeah, you can calculate sunrise and sunset. Really good question. Obviously, if it's sunset, this person will get the sunset earlier and this person will get the sunset later. Same thing with sunrise and sunset as well. So that is if they're in the same time zone. So you've always got to be careful of this thing in the same time zone. If you're in the same time zone, just think of everyone has their watches there. Sometimes we've got to change times between, like how far, like if it's 2 p.m. here, what time is it over here or whatever. But it all starts at this international date line. We would be the earliest. That's why, you will see that our time is normally +10, because if you think about why it's +10, so how does this work with these time zones? If it's 0, the UT sign here on 0 is 0, 0, 0, 0. If you move easterly, you're adding time. If you move westerly, you're going to subtract time. So easterly, add time. If you move westerly, take time. Because these guys haven't had their day yet. Like if it's midday, just say if it's midday in England, well, we would have already had our midday. So you've got to add time on. So midday would be 12 plus 10 hours. So that would be 22, so it'll be 10 p.m. Whereas if you're westerly from here and you didn't cross the date line, then that's going to be early. You still haven't had your whole day yet. So Melbourne is located at 38 degrees south, 145 degrees east, and Jakarta is located at 14 degrees south, 101 degrees east. What is the time difference between these two cities? We ignore these souths. Okay, it doesn't really matter if on south. The difference is in the easterly. Now, what we need to do is we need to look at the easterly difference. Well, it's 145 minus 101. So if you look at that, where's my calculator? 145 minus 101 is 44 degrees, right? We can times that by 4 minutes if you want, or you can just go 44 divided by 15. It's approximately 2.93 hours, so it's pretty much 3 hours. Now, it says correct to the nearest half hour. Correct to the nearest half hour, what you're going to do is you're going to go -2, because it's 2 hours, times that now by 60 to figure out how many minutes. It's 2 hours and 56 minutes. Therefore, it's 3 hours. Now, if it didn't say this, correct to the nearest hour, and this is where people go wrong in the exam. If it just said, what is the time difference between 2 hours? If you answered 3 hours for this, you'd be incorrect. You need to say 2 hours and 56 minutes. I mean, yes, everybody in the international date line rounds off to every half an hour or an hour, right? But if it asks for what is the difference between time difference and it doesn't say round it off or anything, you need to figure it out exactly. For a 15 degree in longitudinal, there is 1 hour time difference. So that's one of the key factors. When it's 9 p.m. in New York City, it is 4 p.m. in Honolulu. If the longitudinal of New York City is 74, what is the longitudinal of Honolulu? Well, if we look at this, what's the time difference between it? The time difference between these two is 5 hours, right? So we're talking about 5 hours. So we know that 5 hours times 15 degrees, it would be a 75-degree difference. Now, the trick here is to go, well, do I add it on or do I take it away from the latitudinal? So we've got New York. So how I do this, New York is, what is New York? New York is 74. Is that right? 74 degrees. They don't say east or west. They should. And Honolulu. What is Honolulu? So New York is, and what time is it? 9 p.m. And then we've got Honolulu. Question mark of that. We know it is 5 p.m. I think it was 4 p.m. 4 p.m. So we've got a 5 hour difference. Therefore, we know that we've got 5 times 15 degrees is going to be 75 degree difference. Now, if it's 9 p.m. in New York, right, if you think about this, if it's already late in New York, remember the Earth rotates this way. If it's 9 p.m. here, 9 p.m., where would it be earlier? Well, if you went this way, it would be getting, 9 p.m., it would be later this way, easterly. So it's earlier. So that means because you're actually going in Honolulu, 4 p.m. would be over here. So you're actually taking away. Okay, so therefore we're moving westerly because it goes that way. So later occurs more easterly. Earlier, more westerly. And that is a key diagram. Whoop, I shouldn't have drawn two circles. That is a key diagram for you guys to have. So what I'll suggest is doing that if you, later, more easterly, and earlier. Is more westerly. So because it's earlier, I know I need to move westerly. Therefore, I need to take 75. So it would be 1 degree. Well, I don't know where New York is. Is New York west? This is why it's silly, because if it was easterly, then it would be, this would be 1 degree west, right? If that was 70 degrees east. However, if this is 74 degrees westerly, then this would be 149 degrees westerly. You with me? So I don't know if New York's east or west. So let's look at the solution. New York City is 5 hours, so it's 75 degrees. The difference in longitudinal is 149. So it must be westerly. Yeah, it's 149. So that wasn't a very good question because it didn't give me if it was degrees east or westerly, but it was really good to talk about and look through it and looks at the two difference there. So that's the difference in time zones. Now, that's kind of an easy one, looking at the time zones between two cities. It does get more challenging than that. I don't think they've got enough worked examples in there. I do like the difficult question that I gave you guys. I'm just going to choose another one for you just to go through with this. Further maths is where I want to go. Where's the difficult questions? I did have them. Sorry, just bear with me. That's the one I want. Okay. No, we'll leave it there. Stop that.